Welcome to Mastering Solutions. So this question is actually pretty straightforward. I think some students might just get confused on how to set it up because it seems confusing. But if we think about what's happening, we'll say we have our rod here. So this is our glass cylinder, the glass rod, and it's submerged in oil. So if we zoom in to this section right here, we have light traveling down this. And what is a critical angle? That means what angle are we going to have total internal reflection? So instead of getting any refraction through the glass, all of it would bounce back into the glass here. That angle, that's what we're trying to solve for. And it's this angle right here. So theta sub c, and this is also theta sub c. So these are equal to each other. So to find the critical angle, or the angle for total internal reflection, we're going to use the equation given in the book. So theta sub c is equal to the inverse sine of n2 divided by n1. One thing that can be confusing is people don't know where to find the n's. We know that we have the glass rod, and so which one do you use for which, right? And so you can look in the chapter. There's a table where they give a list of many different indexes of refraction. And so we'll say our N1 is going to be the glass, which is 1.50, and the N of the oil is 1.46. So the N1, that is the index of the medium that we're in. The N2 is the one that's outside of this. So now plugging that in, theta sub c is going to equal to inverse sine of 1.46 divided by 1.50. If you think about this, it needs to have the larger one on the bottom and the smaller one on the top. If you don't, you will get an incorrect answer. And to illustrate my point with that, let's say we get it mixed up and we say, we have the inverse sine and we put the glass on the top, 1.5 divided by 1.46, you're going to get a domain error. So it's kind of fail-proof, I guess, in that way. But when we plug this in, we have the inverse sine of 1.46 divided by 1.5. So the critical angle for this is going to be 76.7 degrees for this glass rod submerged in the oil.